Roots and radicals, negative variables. In many of my roots and radicals videos, I have the following disclaimer that for the purposes of this video, I will assume all variables represent positive values, and to please understand that they can be negative. So if your book or class does not restrict it, then you must remember the square root of a squared is the absolute value of a. This is actually true for any even root of a variable resulting in an odd power. All right? So what if your book or teacher doesn't assume all variables represent positive values? So let's work just a couple of examples to see. Now, let me say this about this video as well. This doesn't get really deep into this, but I just want to show you a few examples of it. I mentioned a few other things in some of my other videos, depending on how the problem starts. All of these start as just a single radical, so then this rule applies about the even root with an odd power that comes out kind of thing. If you start with 2 and multiply or divide, then what you start with may already restrict it to only be positive, so you got to pay attention to that. But I just wanted to give you a few examples here of this. So when I look at this, I say, okay, my index is 2, and how many times will 2 go into 3? Well, it goes into it 1 time, and then under my radical, I have 1 left over. Okay? Remember, that's 1 and 1/2 for my mixed number. The deal here is if x is not understood to be positive, then the square root of x squared has to be absolute value. Okay? I was doing something crazy. This is my board. All right. So then absolute value of x, because it came out as x to the first power, which is odd, from an even root 2. Okay. So if we don't assume that the variables have to be positive, then or represent positive values, then this is going to be absolute value of x times the square root of x. Okay. That's what that is. And then for this one here, the square root again, 2 goes into 8 how many times? 4. So that's x to the 4th power with how many left over under the radical? None. So do I need an absolute value on that? No, because the 4th power is what? Even. So even if your x was a negative number when you raise it to the 4th power, it doesn't matter. The same number, positive or negative, raised to the 4th power is going to be the same thing. Okay. So, and then y, so 7 divided by 2, or 2 goes into 7 how many times? 3 times with how many left over? 1. Now this y to the 3rd must go in absolute value because 3 is an odd power, right, that came from an even root 2. So the x to the 4th is okay because it's an even power, but the y to the 3rd is not okay. It's got to go in absolute value. All right? So I hope you're having fun already, right? The square root of 48 x to the 5th. Well, here we have, again, square root. So how can I break 48 up? Well, 48 is 16 times 3. And the reason I don't do something else like 24 times 2, what's the square root of 24, the square root of 2? I don't know. I don't have, they're not perfect squares. I choose these two numbers. I don't even pick 12 and 4 because 12 and 4 are not, well, 4 is, but 12 is not a perfect, 16 is the biggest perfect square. I'll pick 6 and 8. Okay, I could pick 4 and 12, but then 12 also has 4 times 3 in it. You keep going. But here, the biggest perfect square that goes into 48, 16. The square root of 16 is 4, and then under my radicals, there's a 3. I left space here, again, because I looked up here and said 5 is bigger than 2. There's going to be x's that come out right here, okay? So here, the 3 under here, right? And then x to the 5th. 2 goes into 5 how many times? 2 times with 1 left over. Do I need absolute value on that? No, because that's an even power. Even power from an even root, fine. Right, again, when you square x, it doesn't matter if x is positive or negative. Then you square it, it's going to be positive. For real numbers. For real numbers. So let's keep looking at some of these. All right. The cube root of x to the 16th. So I say 3 goes into 16 how many times? Well, 3 goes into 16 5 times with how many left over? 1, because 16 over 3 is 5 1/3. Do I put absolute value around the x to the 5th? It is an odd power, but did it come from an even root? No, it came from an odd root. So when odd roots, you don't ever worry about absolute value because you can take a negative number and raise it to an odd power, and it can be negative, and you can still take the root of it. So you're fine there, right? I just wanted to throw that in here to see, but it doesn't matter here on this one. It doesn't matter. Let me erase my mark I had to make because of my board glitches like that and does funny things, and that's the way I found to fix it, is go to the next page and make a mark. If you look back, it took away one of my absolute value bars on the first problem. So the fourth root of p to the fourth, v to the 17th, c to the third, well, how many times was 4 going to 4? One time, right? And by the way, this is all one term, so this is why this works. We can take it individually. So p to the first power, and then are there any p's left over under my fourth root? No. Does that p get raised or get absolute value? Yes, because what is the power? 1, which is odd, and it came from 4, which is an even root. So absolute value of p, and then, and I guess to make that look more like absolute value of a lowercase p, we'll do that, right? And then v to the 17th. How many times will 4 go into 17? 4 times. V to the fourth with 1 left over. So under my fourth root, I have a v left. This is an even power, so does that need an absolute value on it? No, it does not. And then what about c to the third? How many times will 4 go into 3? It won't go in there, so no c's come out, so all 3 c's stay under here. Now, I left too much space here for my c's, all right, or my v's and my c's. So then I'm going to rewrite this just all together. Absolute value of p times v to the fourth times the fourth root of v c to the third, and that is my final answer there, all right? So when you have negative exponents are possible, when they're possible, negative values are possible, then when you get an odd root from an even power, an odd power from an even root, I said that backwards, an odd power from an even root, then you have to use absolute value. But now pay attention to how the problem begins as well, because sometimes it restricts itself before it starts, and it's not a concern.